Welcome back, everyone, to the Deep Dive. Today we're looking at something pretty wild. AI that can understand, like, really long pieces of text.
Yeah, like when we're not just talking about a long article here, we're talking about like whole books.
Entire books. It's insane. And the team over at Google is really kind of leading the charge on this with their new model.
Titans.
Yeah, Titans. So get ready because we are diving deep into how it works and what it means for, the future of AI and all that.
Yeah, this is a really exciting area of research. It's like, one of the big challenges in AI has been getting it to work like our brains. You know, how we can remember stuff from years ago and use that knowledge to understand new things.
Right.
Getting AI to do that, that's been a big challenge.
For sure. And I guess to really understand how Titans is doing this, we got to kind of start with what's already out there. Like, what's the state of the art right now?
Right.
And, I'm talking about transformers. I mean, they've really changed the game when it comes to processing language. But,
They have a weakness.
they do. Like, when it comes to super long sequences of data, they fall apart a bit.
Exactly.
But trying to remember every conversation you've ever had,
Yeah.
your brain would be fried.
Yeah, it would be way too much. So with transformers, the way they work is they look at how every single word in a text is connected.
Uh-huh.
But as you can imagine, the longer that text gets, the more connections there are, and it just explodes computationally.
Right.
It would be like trying to connect every single dot in a giant, one of those pointillist paintings.
Yeah, it would take you forever.
Forever.
Okay, so that makes sense. So what have researchers tried to, get around that problem?
Well, there are other models like linear transformers and RNNs, and these guys, they're better at handling longer texts, and the way they do it is by kind of compressing past information,
Oh,
like making a summary of what they've already seen.
okay, that makes sense. But I'm guessing that there's some kind of downside to that, right?
Of course, yeah. The problem is when you compress information like that, you lose detail. It's like trying to squeeze all your vacation photos into a tiny photo album.
Oh,
You can't fit everything.
right, you got to cut some of the good ones.
Exactly.
Okay, so we've got these really powerful models that can do a lot, but they have these limitations. And then we've got these more efficient ones, but they have to sacrifice some detail. So is that where Titan's coming in?
Exactly. Titans is basically taking the best of both worlds, and it's inspired by, guess what?
The human brain.
The human brain. It uses separate but interconnected memory modules.
Okay.
You've got one for your short-term memory, like what you're thinking about right now,
Yeah.
and then you've got another one for your long-term memory, like all the important stuff you've learned over time.
Oh, interesting. Okay, and this is where it gets really cool, I think. So Titans doesn't just store information, it actually prioritizes what's important using this really interesting concept of surprise.
Yeah, it's like how you're more likely to remember something unusual or unexpected.
Right.
Something that really stands out. So Titans works kind of the same way. It focuses on the data that surprises its stuff that doesn't fit with what it already knows.
Okay, that is so clever. So how does it actually, how does it measure this surprise in a technical sense?
It uses something called gradients. You can think of it kind of like, imagine a ball rolling down a hill.
Okay.
The steeper the hill, the faster the ball accelerates, right?
Right.
Gradients work in a similar way. The more a piece of information changes Titan's understanding, the steeper the gradient, the bigger the surprise, and that means it pays more attention to it.
So it's learning and remembering by focusing on the stuff that's unexpected. Okay, so does that mean it remembers absolutely everything that surprises it? What about forgetting things?
Forgetting. That's a crucial part. Just like our brains, Titans needs to forget stuff, get rid of the less important details to make room for new information.
Oh, okay, yeah.
It's like cleaning out your closet. You got to get rid of some stuff to make room for the new stuff.
So it's not about remembering everything, it's about remembering what's important. So is there a way that it kind of separates that general knowledge from the specific text it's looking at?
Absolutely. They have this thing called persistent memory. Basically, it's a separate storage area for general knowledge about whatever task it's working on, kind of independent of what it's reading at that moment.
Okay.
It's like having a toolbox with all your essential tools. No matter what job you're doing, you always have those tools.
Oh, that's a great analogy. That makes a lot of sense. Okay, so from what I understand, there's not just one way to use Titans, right? The researchers actually have different ways of using it, right?
Yeah, so they actually create 3 different configurations of Titans, and each one has its own strengths and weaknesses.
Okay.
So the first one is called Memory as a Context, or MAC.
Mac, like the computer.
Kind of, yeah. So in Mac, the long-term memory works like this massive library, and the long-term memory can access it whenever it needs. It's like you're reading a book, but you also have the entire internet at your fingertips.
Wow, so it's like having a research assistant in your brain.
Exactly.
Oh, that's wild. What about the other configurations?
All right, so the second one, this one's called memory as a gate, or MAG. This one's kind of like a filter.
Okay.
So the long-term memory helps prioritize information before it even reaches the short-term memory. You can think of it like having a personal assistant who highlights the most important parts of a document before you even start reading it.
Oh, okay, so it's like helping Titans to kind of cut through all the clutter and focus on what really matters.
Exactly.
Interesting. And the third variant?
Okay, so this one is called memory as a layer, or MEL. This one is a bit more complex. Imagine you have a tutor who's kind of pre-processing, simplifying this complex information before you even open the textbook, right?
Uh-huh.
So MAL's long-term memory basically does that. It makes it easier for the short-term memory to understand.
So it's like it's getting a little bit of a head start.
E.
Oh, that's really interesting. Okay, so we've got these three different Titans, each with their own way of handling memory. But the big question is, do they actually work? Like, do they really perform better than other models when it comes to these really long texts?
Well, the results are in, and they're pretty amazing. Titans and its variants, they're really outperforming other models, especially when it comes to understanding these super long texts.
Okay.
One of the tests they did, they called them Nita in a haystack tasks, where they basically had to find a specific piece of information hidden within a massive amount of text.
Oh, wow. That sounds almost impossible, like finding a specific grain of sand on a beach.
Right. But Titans did it. And not really that, get this, Titans actually beat out much larger AI models on a benchmark called Babylong,
Oh, okay.
which specifically tests how well a model can reason over very long pieces of text.
Interesting. So it's not just about size, it's about how you use what you got.
Exactly. So Titans can handle these huge amounts of data, and it can actually pull out meaningful stuff from it. But were there any times where it struggled?
Yeah, I was wondering about that. Like, are there any limitations?
Of course, no AI is perfect, right? One thing, especially with the memory module, is that it takes a lot of computational power to train it.
Oh, okay.
Remember how we talked about that trade-off, like performance versus efficiency?
Right.
Well, they found that if you make the memory deeper, you get better results, but it also means the training takes way longer.
So you need more powerful hardware to unlock its full potential.
Exactly.
Makes sense. I mean, it's handling all this information. It's got to be doing a lot of processing.
Yeah.
But even with all this, like, is there still a limit to how much information it can actually process at once?
That's a great question. And while Titans can handle way more text than your typical transformer, it still has what's called a fixed context window.
Oh, okay.
So even though that window is much bigger now, we're not quite at the point where AI can read like a whole library and understand it all at once.
Got it. So even with Titans, there are still some boundaries, but it's definitely a huge step forward. Like, what are some real-world applications for this kind of tech? Where could Titans actually make a difference?
Oh man, the possibilities are endless. We already talked about time series forecasting and DNA analysis.
Right.
But think about things like healthcare, scientific research, education.
Okay. Yeah, I'm ready. Paint me a picture. What could it do?
So in healthcare, imagine Titans analyzing a ton of patient data,
Okay. Yeah.
helping doctors make more accurate diagnoses, maybe even create personalized treatment plans.
Wow. That would be revolutionary.
Right.
Okay. What about scientific research?
Titans could go through mountains of data,
Uh-huh.
uncover hidden patterns that we might not even see,
Oh, okay.
and that could lead to breakthroughs in things like climate modeling or drug discovery.
Oh, wow. So, like, solving some of the world's biggest problems.
Exactly.
That's amazing. Okay. What about education? How could Titans change the way we learn?
Okay, imagine AI tutors powered by Titans, right?
Okay.
They could personalize the learning experience for each student, adapt to their needs, give them real-time feedback.
So making education more engaging and effective.
Exactly.
Okay, those are some really impressive possibilities. But with all this talk about the good stuff, we got to talk about the potential risks, right? Like, what about the ethics of a technology as powerful as Titans?
You're absolutely right. It's like any powerful technology, we got to be responsible,
Yeah.
make sure it's used for good. We need to think about things like bias,
Right?
protect privacy, make sure everything's transparent, how these models are built, how they're used.
It sounds like it's not just a tech challenge, it's a societal one too.
For sure. And it involves everyone, the researchers, the developers, but also policymakers, ethicists, the public.
Yeah, everyone's got to be part of this conversation.
Absolutely.
Okay, then we talked about the limitations of Titans, the potential for good, the ethics. But one thing that really stuck with me was this whole brain analogy. Makes me wonder, how far can we take this brain-inspired approach? Could we actually create AI that's as smart as humans?
That's the million-dollar question. Titans is a big step, but the human brain is still the most complex thing we know of.
Right.
And honestly, we're just starting to understand how it works. So it's like you're trying to build something we don't even fully get ourselves.
Yeah, it's crazy to think about, like, we might actually be able to create AI that's as smart as us, but there's still some big hurdles to get over, right?
Absolutely. I mean, one of the biggest challenges is data. Like, to train AI that can really think like a human, we need a massive amount of data. And it can't just be any data, right? It has to be data that captures how humans think, how we behave, all the little nuances.
Yeah, okay, that makes sense. But we hear all the time about how much data there is, right? Isn't that enough?
Yeah, but see, that's the thing. A lot of that data isn't really the right kind of data.
Oh, okay.
We need data that shows us the complexity of human experience. Like, think about brain scans, psychological profiles, recordings of how people interact.
Oh, yeah, okay.
That kind of data is a lot harder to come by.
Right, so data is a big problem. What about the models themselves? Like, are there any limitations to how well we can actually mimic the brain with our current AI techniques?
That's the big question, isn't it? And honestly, we don't have a clear answer yet. The human brain is so complex, and we're really just starting to figure it out. It's kind of like we're trying to build a machine that we don't even fully understand ourselves.
It's pretty wild when you think about it like that. But I guess that's what makes this whole thing so exciting, right?
Oh, absolutely.
Like, there's so much we still don't know about the brain and about the potential of AI.
It's a whole journey of exploration and discovery.
So let's talk about those potential benefits. Like, if we can really crack the code of brain-inspired AI, what could the future look like?
Okay, imagine AI that doesn't just understand and talk like us, but AI that can actually feel our emotions, understand what we're thinking, even work with us creatively. AI that's not just smarter, but more human in the way it interacts.
That sounds like something straight out of science fiction.
I know, right?
But that's exciting. So how would that change things, like practically speaking? What could that actually look like?
Okay, imagine having an AI assistant that not only schedules your appointments, but also knows how you're feeling and gives you advice based on that. Or think about AI therapists that can offer personalized support, really helping people through tough times with empathy and understanding.
Wow. Yeah, okay, those are some really powerful examples. So we're talking to AI that could change not just how we work, but how we connect with each other.
That's exactly it. Imagine a world where AI makes us more creative, more productive, and more connected. It's about transforming our relationship with technology and with each other.
Well, this has been an incredible deep dive into the world of Titans and this whole idea of brain-inspired AI. I feel like we've just scratched the surface of what's possible. Any final thoughts you want to leave our listeners with?
I think the big takeaway here is that we're at this really crucial point in AI development. Models like Titans are showing us that we can do some incredible things when we look to the human brain for inspiration. But this is just the beginning. There's so much more to learn about the brain and about the potential of AI. And as we keep exploring, we have to remember that it's not just about building smarter machines. It's not building a better future for everyone.
Well said. Thanks so much for taking us on this deep dive. It's been a pleasure talking with you.
It was my pleasure as well.
To all our listeners out there, thanks for joining us on this journey into the future of AI. And as always, stay curious.